Today's lesson is on the remainder theorem and the factor theorem. The remainder theorem and the factor theorem use long division and synthetic division to accomplish what you need to get to, so particularly factoring expressions. Don't forget this important memo that if you are writing a polynomial, make sure you write it in standard form, including all terms. That means you sometimes have to write in a coefficient of 0. Example 1, using long division to factor polynomials. We are factoring 6x cubed minus 25x squared plus 18x plus 9 using long division and x minus 3 as a factor. So let's just talk about what this looks like. If we were to write this as a long division problem, we would write this as 6x cubed minus 25x squared plus 18x plus 9. And we would write this as a divisor of x minus 3, or we would write a divisor of x minus 3. Okay, so that's written a little bit differently than how number 1 is worded. Number 1 is telling you that x minus 3 is a factor. But let's back up to something a little more basic. So if I gave you a really basic division problem, such as 6 divided by 24, you would all hopefully know that the answer to this is 4 without going through the whole long division process. So 24 divided by 6, 24 divided by 6 equals 4. 6 right here is a factor of 24. So while it is also a divisor of 24, because it divides perfectly into 24, we could consider it a factor. 6 times 4 is 24, or 24 divided by 6 is 4. You can rearrange these terms in so many different ways, but no matter what, 6 is a factor of 24, and 6 is also the divisor of 24. So the same thing goes for a long division or a polynomial long division problem. If x minus 3 is a factor of 6x cubed minus 25x squared plus 18x plus 9, that means that it's going to divide perfectly, that the remainder is going to be 0. So again, always think back to a basic example. 24 divided by 6, 6 is a divisor, but the answer comes out to be 4. That's your quotient. That means 6 is also a factor. They're kind of interchangeable terms as far as explaining or working with long division problems. All right, so we're going to use long division. I'm going to set this up. X minus 3. Underneath the sign, we have 6x cubed minus 25x squared plus 18x plus 9. We look at our first terms. Off to the side or in your head, however you're comfortable doing it. 6x cubed divided by x is equal to 6x squared. That's the first term of your quotient. Now you multiply the first term of your quotient by both terms in the divisor. 6x squared times x is 6x cubed, exactly what we want for that number right there. 6x squared times negative 3 is negative 18x squared. We're going to divide this entire expression. When we do that, 6x cubed is eliminated. Negative 25x squared minus negative 18x squared is the same thing as adding 18. This is negative 7x squared. Bring down the next term of 18x. Now we have a new first term of the dividend. We're going to divide negative 7x squared with x. This divides out to negative 7x. Negative 7x is the next term in your quotient, which you multiply by both terms in the divisor. Negative 7x times x is negative 7x squared. Negative 7x times negative 3 is positive 21x. Subtract both terms inside of the parentheses. That's going to eliminate your first term. 18 minus 21 is negative 3x plus 9, and that's because I brought down this next term. Now we have a new first term in our dividend. The first term here is negative 3x. The first term in our dividend is x. When we find the third term of our quotient, we have negative 3x divided by x. This is equal to negative 3. Negative 3 is multiplied by both terms in the divisor. Negative 3 times x is negative 3x. Negative 3 times negative 3 is positive 9. We need to subtract both of these terms. Negative 3x minus negative 3x is 0, and 9 minus 9 is 0. So we just went through all that work to show that our remainder was going to be 0, which we already knew because we know that x minus 3 is a factor. However, now we can continue to factor this. Our remainder is 0. We know that x minus 3 is a factor. We know it's a factor of the original dividend. That means that if you have x minus 3 times 6x squared minus 7x minus 3, and you multiply those two expressions together, you're going to end up back at your dividend. Always think about a basic example. 24 divided by 6 gives you the answer of 4, but if you multiply 6 and 4 together, you end up back at 24. Same thing goes here. X minus 3 times 6x squared minus 7x minus 3 gets you right back at the beginning. So the directions of this tell us to completely factor the expression of 6x cubed minus 25x squared plus 18x plus 9. So in order to completely factor it, I'm going to use my divisor, or the given factor, of x minus 3. I'm going to set up the expression. I'm going to multiply it by our quotient, 6x squared minus 7x minus 3. And I'm going to continue to factor because now I can factor a quadratic. I can factor this expression. I need to think to myself, a times c is equal to 6 times negative 3, which is negative 18. So what two factors multiply to equal negative 18, and the same two factors that add to equal your middle term of negative 7. Oops. That would be negative 9, positive 2. So I'm going to rewrite this expression that I'm currently factoring as 6x squared minus 9x plus 2x minus 3. All I did at this point is rewrite my middle term. Group the first two, group the second two. GCF of the first group is 3x. Left over is 2x minus 3. GCF of the second group is positive 1. Left over is 2x minus 3. So this expression has our common factors of 3x plus 1 and I think I said that wrong. This expression has greatest common factors of 3x and positive 1, and then it has a common factor of 2x minus 3. So I'm going to write my greatest common factors of 3x plus 1 as a set or a group, and I'm going to write my common factor of 2x minus 3 as a group. Don't forget that you already had a factor that you started with of x minus 3. So don't forget this factor. All right, This is your final factored answer. So this right here is completely factored from the starting point. If you were to multiply these three expressions together, so use the distributive property, or some of you refer to it as FOIL, but if you were to use that property, you can end up back at the original expression of 6x cubed minus 25x squared plus 18x plus 9. Okay, I'll do the on your own section without talking so you can just follow along and check your work when you're done. For the next section, we need to review synthetic division and also review evaluating a function. So I'm going to go through these pretty quick. Hopefully you notice something similar between the two of them while I'm going through them. Number one is synthetic division. We have 3x squared plus 5x plus 5, and we're dividing this by x minus 3. X minus 3 would give us the synthetic divisor of 3. We're going to set up our synthetic division. Make sure you identify all of your coefficients. Your synthetic divisor goes on the outside. Your coefficients of -3, 5, and 5 go on the inside. You add inside, you multiply on the outside. Synthetic division gives us a remainder of -7. If we scroll over to number 2, we have the same function. So notice in both of these, we are using f of x equals 3x squared plus 5x plus 5. And in this case, we are evaluating the function, but we're evaluating it at a value of x equals 3. Also similar to our synthetic divisor on number 1. Evaluating functions is when you take your x value and you substitute it into the function wherever you see x. For this function, we have f of 3 is equal to -3 times 3 squared, which is 9, plus 5 times 3, plus 5. -3 times 9, or times 3 squared, is negative 27. 5 times 3 is 15, plus 5. When we simplify this, f of negative 3 is equal to negative 7. So what I was planning on everyone noticing is that the remainder for number 1 using synthetic division and the answer for number 2, evaluating the function, both come out to negative 7. You also, again, should notice that the functions are the same and your synthetic divisor compared to your evaluation term, they are the same. So you're getting 2 of the same answers, but completing the problem 2 different ways. So this leads us into the remainder theorem. The remainder theorem says that if you divide a polynomial by a linear expression, such as x minus a, the remainder will be the same as evaluating the expression at a. It will probably be easier to understand the remainder theorem if we just jump right into going over example 1. So example 1 says to use synthetic substitution, which means we have to use the synthetic process to do this, and the remainder theorem to evaluate each function. So if you are using the remainder theorem, you are only evaluating. You do not need to write your final factors. You don't need to write your quotient plus your remainder over your divisor. You are just evaluating. So we are only looking for the remainder. And this is why it's called the remainder theorem. Number 1 says x to the 5th minus 2x cubed minus x squared plus 2, and we're evaluating it at x equals 3. We do have to make sure we include all terms, so rewriting this as x to the 5th plus 0x to the 4th, because we're missing that term, minus 2x cubed minus x squared plus 0x plus 2 will be helpful. Look at all of your coefficients. And what you're evaluating the function at, this is already set equal to 3, or x is already set equal to 3. It is not in the form of a factor, so you do not need to change the sign. You are just going to use the value of 3. Three goes outside. Inside are your coefficients of 1, 0, negative 2, negative 1, 0, and 2. Bring down the 1. 1 times 3 is 3. 0 plus 3 is 3. 3 times 3 is 9. 9 plus negative 2 is 7. 3 times 7 is 21. 21 plus negative 1 is 20. 3 times 20 is 60. 60 plus 0 is still 60. 60 times 3 is 180. 180 plus 2 is 182. So this is your remainder. That is also the answer to your expression, or to your evaluation problem. So we write our final answer as f evaluated at 3. We're using 3 because it says x equals 3. So f evaluated at 3 is equal to 182. This is what the remainder theorem is. Instead of substituting 3 into the problem wherever you see x, you are just going to use synthetic division. Whatever your remainder is, that's your answer. I'm going to go through number 2. You can just follow along with me. I'm not going to talk through this one. I think everyone should be pretty good with synthetic division by now. Okay, so now that we've gone through these two examples, make sure you understand how to write your final answer. That is part of the problem. So understanding that the remainder theorem is specifically looking for the remainder and it's looking for you to write your answer like this is part of this. So you have to write your answer like that on the quiz. I will be checking for that. Next, we have the factor theorem. So the factor theorem says that if the function has a factor, I used x minus a again, then the function has to have a remainder of 0. So we basically started off the notes with this theorem, but we just started off using long division as a review. This factor theorem is going to require us to use synthetic division and then to completely factor the expression. So the first example set 3, is just asking you to determine if the given binomial is a factor. So it's not asking for you to factor the whole thing. It's just saying state yes or no, is the given binomial a factor? You have to prove that it is by showing that the remainder is 0, or prove that it's not by showing that the remainder is not 0. So we're going to go through this the same way using synthetic division. This is not equal to 0. Previously, using the remainder theorem, it would say x equals 5. This is not the case. This time, this is a factor. So knowing that this is a factor, it's in the form of x minus c. In this case, c is equal to 5. Set up our long division. One, -7, 7, and 15 for our coefficients. Bring down the 1 and start the process. Oops. 1 times 5 is 5. 5 plus -7 is -2. -2 times 5 is -10. Plus 7 is -3. Times 5 is -15. Plus 15 is 0. So to answer this question, you would say, yes, x minus 5 is a factor of the original expression x cubed minus 7x squared plus 7x plus 15. And back at the beginning of this video, I explained the whole process of a factor. I used 24 divided by 6, 6 being the divisor, but because it works out perfectly, 24 divided by 6 is 4. That also means 4 is a factor of 24. So how divisor and factor can be used interchangeably if the remainder is 0. So same thing goes here. Because x minus 5 is a factor, or has a remainder of 0, it is a factor of x cubed minus 7x squared plus 7x plus 15. For number 2, your synthetic divisor is 2. We have all terms, so our synthetic division two on the outside, coefficients of 1, -7, 4, and 12. Bring down the 1. 1 times 2 is 2, plus -7 is -5, times 2 is -10, plus 4 is -6, times 2 is -12, plus 12 is 0. So this one is also a factor. I'm just going to say yes for this. We know what we're talking about on that. So yes, x minus 2 is a factor of the original expression x cubed minus 7x squared plus 4x plus 12. And lastly, the fourth example set here says to use the factor theorem and determine if the factors, to determine the factors of the polynomial. So this is just like that first one. Now we're using synthetic division. We have to completely factor the entire expression here. Using synthetic division for the first one, our synthetic divisor is 5. 5 goes outside To complete the synthetic division, bring down your coefficients. We have 1, -7, 7, 15. 1 times 5 is 5, plus -7 is -2, times 5 is -10, plus 7 is -3, times 5 is -15, and 0. So yes, we have a factor. That's telling us that this here is what's left over. We would have x squared minus 2x minus 3. All right, so this being the quotient, this being a factor or the divisor, we can write an expression that says the divisor, or that states the divisor times the quotient equals the dividend. I'm not going to write that out, but it equals the dividend. And then underneath this, I'm going to write that our divisor is x minus 5, and our quotient is x squared minus 2x minus 3. You need to think and determine if that is factorable any further. It is. So our final answer is x minus 5 times x minus 3 times x plus 1. And the -3 and +1 multiply to -3 and add to -2. That's where those factors came from. This here is your final factored answer. And for the last problem, we have our synthetic divisor of -4. We are missing a term. We need to add in 0x. Bring down the coefficients of 1, 3, 0, and 16. 1 times -4 is -4. 3 plus -4 is -1. -1 times -4 is 4, plus 0 is 4, times -4 is -16, which is equal to 0. Our quotient is x squared minus x plus 4. Now, this is the quotient, so we can write it as the quotient times the divisor, and that's equal to the dividend. And you just have to check to see, is this factorable? So are there two factors that multiply to +4 and add to -1? And the answer would be no. So this is your final answer, x plus 4 times x squared minus x plus 4. If you were to multiply those two expressions together, you would end up back at your original expression of x cubed plus 3x squared, plus 16. So for this note sheet, I can't stress enough how important it is to understand the different terms and how you can use different names for different things. I'm going to go over the same example I've gone over a bunch of times. I hope that everyone remembers what I'm talking about after you've seen this like 5 times on this note sheet. But if you have 24 divided by 6, 6 is the divisor, 24 is the dividend. We would write this as an expression in long division like that. Your answer is 4. 4 is your quotient. Now we have 6 times 4. 6 times 4 is 24. So our quotient and our divisor multiply together to equal the dividend. Okay, this only happens if the remainder is 0. Obviously, we're not doing anything as simple as this, but thinking about simple examples is what helps you realize what you're doing for more complex work. Also, the last big takeaway from this note sheet is please read directions and make sure you're understanding how to write your answer. So are you using the factor theorem or are you using the remainder theorem? How are you supposed to write your answer? Make sure you refer back to this note sheet and write your answers the same way I did.